Hi everyone. Today we are going to be talking about dot plots and we are going to compare them as well. We're going to review what it's like to create a dot plot. So please make sure you have your notes printed out. This is also calculator active because we're going to review a couple of things like mean absolute deviation. All right, so to review, a dot plot displays data graphically using a small dot for each data piece. The data points are ordered from least to greatest. Sometimes you'll see a dot plot, instead of using dots, it uses X's. And sometimes we also call it a line plot, but they're both describing the same type of data in the same graph. Data can take on three different shapes. So it can have a symmetric shape, which means if you folded this exactly down the middle through the median, what's on the right would typically match up with what's on the left. And again, it's a general shape. It doesn't have to be perfectly symmetric, but something that looks close to symmetric will work as well. We also have skewed to the right. So if you look at this graph right here, we've got our data and the tail is on the right-hand side of the data, so we call that skewed to the right. And then we have skewed left, which is in the opposite direction. You've got the tail of this data is on the left-hand side. So we can talk about shape when we look at graphs. We can talk about the spread. The variability or spread in the data points describes how far apart the data is from one another. This can also be represented by the range. The center might be like the median. So it's the median and the mean are both represent the center of the data. When the data is skewed, like skewed right or skewed left, then the median is the best representation of that data. But when the data is symmetric, the mean is the best representation of the data. We've talked about this before when we just described outliers. If there was an outlier in our data, we typically want to use the median as a representation of the center of the data. When there's not an outlier, then it's acceptable to use the mean to represent the data. Okay, we're going to use this information for room 434 and room 425 to create a dot plot. Then we're going to use our dot plots to answer the questions about the data. We've got two different classrooms. They were asked how many minutes each student traveled to school in the mornings. So if you look at your line graph, you'll see that you have all of your numbers represented from 1 to 10. What this shows you is that our data is anywhere between 1 and 10. Please note that our number line is not skipping any numbers. Okay? So your number line is literally the number line. It's not skipping anything. Our data, so our data up here for room 434, that's what we're going to plot on that number line. I've had students in the past think that the only numbers that we put down here on the number line are our data pieces, but that's just untrue. Okay, so how we're going to plot our data is once we have our number line set up, 1 through 10, I'm going to put a dot wherever I see that number occur. And again, I'm only doing room 434 on the left-hand side graph. So I've got a 5, and I just put a dot right there where the 5 is located. Then I have a 7. I'll put a dot here where the 7 is located. And you can even mark them off as you go. And your dots don't have to be perfectly symmetrical. You just try to make them about the same size and at the same height. Okay, then I've got an 8. Let's see. And then I've got another 8. So if I have a second dot that's on that same unit, I just put it above the one that came before, so I'm stacking it. I've got a 4 and another 4. So again, you want them to be about the same height. So my second 4 is about at the same height as my second 8. I have a 7, a 5, a 4. So there's my third 4, and then another 7. All right. It's always a good idea to go back and count your data points. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. And then up here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. That way you know you didn't skip anything. On to the next, room 425. Why don't you stop the video here? On your notes, go ahead and plot your data. When you're ready, press play and we'll go through it together. For room 425, I've got a 4, a 5, and a 5, a 6, a 3, another 6, a 4, 7, 5, and another 5. And again, whoops. It's good to go back and check all of your pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Great. Okay, so my graphs I can tell are two very different shapes. Describe the shapes. Well, it looks like the graph or the dot plot of room 434 doesn't really have a pattern, while in room 425, the data is symmetrical. So now we're going to go through and determine the median in each data set. So to find the median of each data set, you're going to cancel out or eliminate the highest and the lowest value simultaneously. So on a dot plot, this is what it could look like. I'm going to cancel out or mark through a low number and a high number. So I just marked out an 8 and a 4. I'm going to mark out another 8 and another 4. I'm going to mark out a 7 because that's my next highest, and a 4. Another 7 and a 5. A 7 with a 5. So as you can see, I have the same amount of pieces of data marked out on the left-hand side of the 6 as I do on the right-hand side of the 6. So my median is halfway between 5 and 7, which is 6. Another way you could do it is you could list your numbers in order from least to greatest. But if you remember, the data points are already ordered when I have them on my graph, but you could reorder them if you wanted to. I had a 4, a 4, a 4, a 5, a 5, a 7, 7, 7, 8, and an 8. And I could go back through and do the same thing. And this is just what I did on the graph, except in a straight line. And as you can see, we get to a 5 and a 7 exactly in the middle. And what did we do last time? We averaged them together and divided by 2, and that gave us 6. So 6 is the median for room 434. I'm going to do the same thing over here on the right-hand side for 425. I'm going to cross out the highest and the lowest data point simultaneously. As you can see, as I'm doing that, the rest of my data lies right here in the 5 spot. So the median minutes traveled to school in room 425 is 5. The difference between the center of room 425 and 434 is just 1 minute. Remember, difference in math means subtract. So I just did 6, take away 5, and I got 1. So all in all, the minutes traveled to school for each group of students is very close. In room 434, I have 6 minutes. In room 425, I only have 5 minutes. Although the way that their data is laid out is different. It looks different. Okay. Using that information, we're going to answer the following questions. We're going to actually decide if they are true or false. The distribution for room 434 is symmetrical. Well, 434 is this room here. We said that's a no. That data is not symmetrical. The data over here is symmetrical in 425. So the first one is automatically false. The median number of minutes in room 425 is greater than the median number of minutes in 434. Well, we also said that was false. We had a median of 6 over here, a median of 5 over here. So 434 should be greater, not 425. The next one, room 434 has a smaller range. Okay. Remember from last week, range was the highest minus the lowest. I'll start with room 434. The range was 8. The range was 8 take away 4, which is 4. And with room 425, to find the range, I would take the highest, which is 7, take away 3, which is also 4. So this has to be false because their ranges are equal. And the last one, the distribution for room 425 is symmetrical. Well, we said that was true, while the distribution for room 434 is skewed to the right. This one's a little bit more tricky to see, but if I draw a line over my data, I would say that my tail of my data is on the right-hand side, and that could make this a true statement. Okay. Now we're going to use the same data to calculate the mean absolute deviation of each classroom. Then we're going to answer the questions below. Okay, I'm going to walk through room 434 with you, and I'm going to let you do room 425 by yourself. First, I'm going to review how you find the mean absolute deviation in case you forgot. First, in my chart, I wrote down all the minutes traveled to all my data. This data I actually used from the picture here. I put the data in order, 4, 4, 4, 5, 5, 7, 7, 7, 8, 8. I just went ahead and listed it in order because it's easier for me to deal with the data that way. And then I found the mean of the data. Remember, when you find the mean, you add up all the numbers and divide by how many there are. So in this case, I did 5 plus 7 plus 8 plus 8 plus 4 plus 4 plus 7 plus 5 plus 4 plus 7 in my calculator. And then I divided all of that by 10. So I added it up and I divided by 10 because there are 10 pieces of data. Okay, make sure you have all of that down, as that's how you find the mean. When I did that, I got 5.9. So each of these all the way down would be 5.9. Down there at the bottom where it says total, you actually don't need to total up this box. So you can leave that blank or just draw a line through it. Now, once we have the mean of the data, I'm going to see how far each data point is from the mean. We call that deviation, how far away something is from the mean. To do that, we're just going to write a simple subtraction problem. I'm going to take my mean and subtract my data point from it. My mean was 5.9, take away 4 is 1.9. Well, all of those are going to be the same exact thing. If I take my mean again, 5.9, and take away 5, I get 0.9. And I've got 2 data points just like that. And then if I take my mean and subtract 5.7 from it, I actually get a negative number. But as we talked about before, mean absolute deviation means we're taking the absolute value of the deviation from the mean. Because distance, we're measuring distance here, and distance can't really be negative. So I'm taking the absolute value of that number in case it was a negative. In this case, it was. So what we're saying is the number 7 is 1.1 units away from 5.9. I've got 3 data points that were exactly the same. And then I do the same thing for the number 8. The number 8 is 2.1 units away from 5.9. Okay. What we're going to do here is we're going to add up all of our deviations. So all of the positive differences. When you do that, you get 15. But we're going to divide that by how many we have. So 15 divided by 10 is 1.5. So the mean absolute deviation of room 434 is 1.5. All right, let me just explain that one more time. We found the mean of all of our data points. We found how far away each data point was from the mean, and then we found the mean of that. This tells us that each data point is about, or on average, 1.5 data points away from the mean for room 434. What I want you to do is I want you to find the mean absolute deviation in room 425. I'm going to pause the video, I'll let you work, and when you're ready, you can push play and the answers will reveal themselves. Okay, for room 425, we found the mean to be 5. So I went through and put 5 down on my chart. And then I wanted to see how far away each piece of data was from the mean. The first data point was 2 units away, and then 1 unit away, 1 unit away again. Then I have 4 data points that are exactly the same amount as the mean, so those are 0 units away. And then I have another data point that's 1 unit away, another data point that's 1 unit away, and my last data point is 2 units away from the mean. When you add up all of those deviations, you get 8. But remember, you have to divide by how many there are, and there are 10. So the mean absolute deviation of the students in room 425 is 8/10, or 0.8. So it has a lower MAD than in room 434. We're going to answer these last 2 questions together. Some observations we can make about the mean absolute deviation in each classroom. And how is the difference in the centers related to the variability in each classroom? So just to kind of recap, the centers were the mean and the median, right? And the variability would be the range or the MAD. Okay? So they are 2 very different things. Measures of center are the mean or the median, whereas variability is the range or the MAD. All right, so to sum it up, the observations that we're going to make about the mean absolute deviation: the MAD of room 434 was 1.5, and the MAD of room 425 was 0.8. Room 425 has data that's closer to the mean, and there's slightly more variability in room 434. When the MAD is higher, that tells us that the data is a little bit more spread out. So in room 434, the data is a little bit more spread out than in room 425. Number 8, the difference of the centers is 0.9 or 9/10. And that's closely they are closely related to the variability in room 425. So the centers and the variability are super duper close when we look at room 425 than in room 434. Remember, when you're comparing data, you really need to have all of your skills from finding the mean, median, range, and the MAD. You need to make sure all of those skills are up to date so that you can use those skills plus your ability to plot data points, look at their distribution and their shape, and apply that to comparing two different data sets.